Good evening, all of you. Today we are going to define what is a test charge and the work done. So, to understand this, assume we have a positive charge at the origin and then you have a test charge. So, both are positive, so it experiences a repulsive force. What you have to assume is this plus q will not change its position or electrical field properties. That means, because of this test charge, this is not going to affect this plus q position. If at all, if this plus q tries to move this plus capital plus Q charge, then you can assume that some external forces is acting on that such that it always remains at the origin. That means, if you assume positive charge to be very big, then the test charge you can imagine a very small, a pointed charge like that. So a test charge cannot affect the electrical properties of the electrical field properties of plus Q, and the position of plus Q is not altered. This you have to remember. So suppose I try to move this test charge from point R to point P. So a work has to be done. Because both are positive, there will be a repulsive force. Similarly, if both are negative, also you will see a repulsive force. And positive and negative, it will be an attractive force. Just to explain how work done is defined, for that we assume that both the charges are positive or negative. So here we assume both the charges are positive. So now this plus Q, initially it was here and it is trying to move. So there is a small repulsive force. Now once again, if you start proceeding towards this plus Q, there will be a greater repulsive force. Okay. Now assume that I am bringing this test charge from this point to this point, and I am holding it firmly. Firmly means this is also not moving anywhere around. Suppose if I release that supporting force on plus Q, then it may go to its original, it will go to its original position. So a work if at all this plus Q has to move from here to here, a work has to be done. So suppose if plus Q moves from this point to this point, say this distance is very small. I am calling it as dr. Okay, small. So work done, work done is equal to force into displacement. Here the displacement is dr. Both are vectors. Okay. Suppose I want the work done from R to P because of the external force, so that this test charge moves from this point to P point, then I have to go for integration. So that's why I have written external force dot product with dr will give you what? The work done. Now I want it for the entire stretch of this line from R to P. So you have to integrate from R to P. so that you will get the work done from R to P. So when the test charge tries to move from R to P, as it approaches towards plus Q, the repulsive force will be greater. So you have to overcome that repulsive force, then only a work has to be done. Then only you can move this plus Q from this Q. If you don't overcome that force, then you cannot move this charge towards this plus Q. So that's the idea behind a test charge and the work done. Hope you have understood the concept behind test charge and how work done is found out in electric field region because of two charges. So generally a test charge has the property that will not affect the electric field produced because of some other charges, and the position of this plus Q is not altered because of this plus Q. Therefore, if you try to move this test charge from one point to another point towards this plus Q, then a work has to be done. If it is a very short distance, then you can find it by F dot dr, or if you want to see along the stretch of a line from say R to P, then you have to go for integration, then you can find out the work done from R to P. Thanks for watching this video.